Now let us just turn these things into a little bit of mathematics. So this one is what we call the RSS, the residual sum of square. That was the acceptable thing. We first fit the base model, the model which we know is a good fit, and then we fit that restricted model to get this vector, this oblique thing, and that residual sum of square we call RSS1. We subtract one from the other, and we are trying to see whether RSS1 minus RSS is significantly large compared to RSS. That is important. We cannot absolutely threshold this quantity. We have to do it relatively. So what's the most natural thing but to work with RSS1 minus RSS, the extra thing, divided by this accepted thing, RSS. So you are basically expressing the extra thing in unit of what is acceptable. So how many acceptable units am I adding extra? Naturally, if this number is large, you tend to believe that no, my extra error is too much. And if this is small, then you are happy. So intuitively, this should be our test statistic. And indeed, that is the test statistic. And not only that, this has two additional benefits. One, if you just carry out the idea of likelihood ratio test, which is a very routine way of constructing a test in any given situation, if you blindly follow that, then after some linear algebraic jugglery, you will find that that is precisely the test statistic that you get. That is one nice thing about it. So it has got some theoretical justification also apart from the heuristic justification that I just mentioned. The other thing is, once you have this test statistic, you will be interested in finding its distribution, especially its null distribution under the null hypothesis, because you have to find critical value, p-values, etc. In general, that may not be a very easy problem, but in this case, under the Gaussianity assumption, you will find that this has a very nice standard distribution. It will have an F distribution. Well, I would qualify that remark a little bit. A scale version of that, after you divide by suitable degrees of freedom, that will become an F statistic. Not only that, it will have an F statistic, F distribution under null hypothesis as well as under the alternative hypothesis. And alternative hypothesis means that the X1 is not possibly a good fit. So X1 is not a good fit, and X is of course always a good fit. So under null hypothesis, the F will be a central F, and under alternative it will be a non-central F, but we shall take up all those things in a later video.